Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we are discussing the cut protective textiles. So, in this at present we are discussing the materials for cut protection, different types of textile fibers, yarns, fabrics used for cut protective textiles. So, as we have discussed that para-aramid, ultra high molecular weight polyethylene, stainless steel blends, they are mainly used for cut protective textiles. So, para-aramid like Kevlar, which was developed by DuPont. So, they have very high strength. It is the most important high performance aramid fiber used in many applications of high performance applications, including the cut protection. It has got special molecular structure. In 1965, DuPont introduced this fiber under the trade name of Kevlar. It has got very high strength, high Young's modulus, high tenacity, low creep, low elongation at break, which are basically ideal for high performance fiber, particularly in the cut protection. So, all the characteristics which are required for cut protection is present in Kevlar. The properties, if we see for Kevlar, it is high tensile strength. For basic grade around 23-25 gram force per denier, very high strength, elongation 3 to 4%, it is a basic grade. But technical grade, high grade, we can, if we use the, it will be much higher strength. So, it is a aramid fiber, para-aramid fiber, aromatic polyamide. It is a long chain continuous filamentian which exhibits very high tenacity and lowest elongation at break for the textile yarn. So, which are basically required for protective textiles. It has got very good dimensional stability, and Kevlar's cut resistance remain essentially unchanged even after cleaning, washing. Basically, it is a dimensional stable and it is not affected by the water or any normal chemicals. Even the Kevlar yarns tensile strength decreases slightly in this process, but it is not that significant. So, the material retains its cut protective performance. It is very good heat resistant. So, it has to high temperature here and can maintain its strength even at cryogenic temperature of 196 degree Celsius. So, that high temperature resistant, it can, because many applications where the cut situation the temperature is high, there polyethylene cannot be used. Ultra high molecular weight polyethylene, their melting point is low. Okay. And it has actually, it degrades under UV light. That is the little bit problem with the para-aramid. Outdoor UV causes discoloration and reduction in tensile strength in most of the polymeric fiber, but in case of Kevlar it does not decrease much. So, here its UV protection is there, although most of the fibers there is a decrease, but here in case of Kevlar the effect is not that prominent. High cut resistance is there, for that Kevlar is very widely used in cut protection. So, it resists cut very well. So, for para-aramid fabrics, every additional gram per square meter, so if we add the mass, every additional gram per square meter of material typically adds 1.7 to 1.9 grams force required to achieve 20 millimeter cut through. So, that is important here. This is this data is from one of the studies published. So, if we increase the fabric mass per unit area, areal density, we can get the higher cut resistance. So, this is true for other fiber also, other type of fabric also. When we use the thicker fabric, heavier fabric, that will result this higher cut resistance. For example, 300 gram per square meter Kevlar fabric would expect, it will be expected to need roughly 510 to 570 gram force in those tests. Okay. Now, toughness and ductility, high modulus and very good toughness. Kevlar has high specific modulus, as we have already seen earlier. It is found that Kevlar grades reaching from 72 to 110 gigapascal, supporting resistance to indentation or cut initiation. So, that it will resist the cut initiation, that is important. So, applications are wide, like sheet metal handling, sharp edge slipping sheets create severe hand and forearm hazard. It will create severe hand and forearm hazard. Cut resistant gloves, even sleeves, they are routinely used in the industry. Glass manufacturing and handling industry, which where semi finished or broken metals actually that frequently cuts hand arms. So, during carrying and positioning, so cut protection is required. Food processing and slaughterhouse, So, that in that case frequent high force knife that the workers get injured with this type of. So, of knives. So, here in this very high threat is that. So, there steel chainmail gloves are used made of steel wire for highest risk. Recycling and waste handling, unpredictable sharp objects are there, maybe broken glass, knives, cans. So, that may actually pierce in our hand. So, that cut resistant gloves are essential during routine collection and storing. So, apart from this, I have already explained there are many other industries. Next material is that ultra high molecular weight polyethylene. The industry trade name of some commercial fibers are Dyneema, Spectra are very commonly used. This ultra high molecular weight polyethylene, this is a resin used to make high performance polyethylene HPPE fibers marketed as Dyneema by DSM and Spectra by Honeywell Allied. Okay. So, ordinary polyethylene fiber which we get, it has actually the tenacity typically 4 to 8 centinewton per decidex. But in case of HPP like ultra high molecular weight polyethylene, where we achieve very high strength and stiffness through a specialized spinning, that is gel spinning and super drying process. And during this gel spinning and super drying process, this orients the molecule to ultra long chain. So, that and this is the main reason where we get very high tenacity as compared to the normal polyethylene fiber. So, ultra high molecular weight polyethylene, that is the main polymer fiber, is a simply polyethylene fiber with a chain of repeating chain of CH2 CH2 bond. So, that is actually that it is a simple polyethylene, but it is produced in different way. Okay, by producing by specialized gel spinning and super drying process, that makes the fiber so unique. So, the properties are, it is a super high tenacity. So, earlier it was normal polyethylene, we can see the strength was 4 to 8 centinewton per decidex. From there the ultra high molecular polyethylene, its most HPP grades, that is a 30 to 40 centinewton per decimeter, 10 times increase is there, and some Dyneema grades are 40 centinewton per decidex, well above the basic pararamide. So, basic pararamide is around 23 to 25 centinewton per decidex, but it is much above that. But pararamide can also be developed for high tenacity, also super high tenacity, high modulus and low elongation here also, as we have seen earlier in a diagram. So, 90 to 120 gigapascal with 3 to 4% elongation, okay. And that is actually that supports the resistance to traverse indentation, like when we traverse the knife, that type of cut process, this actually this is very highly resistant. So, for cut resistant material, that ultra high molecular polyethylene is very widely used. The properties, if you say outstanding abrasion resistance, okay, the grey 13 gauge HPP glove can reach EN 388 abrasion level with level 4 without coating, and if you add coating then it can go higher, even higher. So, without coating it abrasion level it reaches 4. So, outperforming nylon 66 and para-aramid, and okay, para-aramid basically typically goes up to 1 to 2 level. So, highly abrasion resistant, smooth, low friction surface, also generates little dust and low. So, due to the low friction, what we get here, the same smoothness reduces the grip. Okay. So, here the problem with the low friction. So, if we produce the gloves with ultra high molecular polyethylene, due to the low friction, the grip, that knife, suppose someone is holding, that may slip out. So, to avoid this problem, polyurethane or nitrile coating is done, or textured surface is used to improve handling. If we use a flat filament, then it is due to the low friction, it may slip off. So, to improve the grip, so inner side on the palm side is actually coated with the PU or nitrile coating to enhance the friction and increase the grip. So, adhesion is tricky because HPP is inert surface, relies on strike through basically mechanical keying rather than the chemical bonding, that is important here. Now, here the HPP, high performance polyethylene, they do not normally react because they are inert fiber. It is polyethylene chain, long chain polyethylene, they are inert. So, we cannot give any coating, we applied any coating with the chemical bonding, that is not only by the, like in a structure, textile structure, this is the type of surface, maybe woven, knitted, any surface, and the PU and PU nitrile or any other coating when we apply on the surface, like we are trying to apply on the surface, these are the coating material. And due to the textured structure, okay, uneven structure, these materials are bonded by mechanical bonding, mechanical locking is there. So, it is called mechanical keying, okay, not by the chemical bonding. So, when it penetrates, so there will be a bonding. So, this fiber will be blocked by this coating material from both the sides, so that it is a locked, basically physical bonding we can say. Next property is its excellent UV and weathering resistant. So, HPP retains its strength and show little discoloration after long outdoor exposure. So, useful where products actually is used in the sunlight, that type of application where the sunlight is there. So, we can very well use this ultra high molecular polyethylene. It is a very high chemical resistance, super chemical resistance, because of the there is a absence of any group. So, HPP is resistant to acids, alkali or polar solvent. No reactive groups are there. It is inert material. So, allowing more laundering option than para-aramid. Its cut resistant is as per ISO or ASTM standard straight blade test. HPP typically contributes around 1.4 to 1.6 gram force per GSM, that is for per 1 gram per square meter increase in fabric mass per unit area, the gram force required for 20 millimeter cut through distance typically 1.4 to 1.6 gram force. To cut the cut force 10 to 20% lower than the para-aramid. Okay, around this one to cut force, and typically it is a 10 to 20% lower than the para-aramid. Now, let us see what was there in the para-aramid. At the para-aramid the value was, we can go back, (1.7) to 1.9, okay, 1.7 to 1.9 per gram for okay, GSM, and here typically it is a 1.4 to 1.6, that means typically around 20% lower than the para-aramid. The applications are, so cut resistant gloves, sleeves are there. These are used for outdoor applications, and here at this is as it is a very inert. So, we have, and its friction is less, we have to use the coating also. So, HPP its high cut resistance and abrasion performance, its low weight, cool fill, because low weight because of the lower density, and cool fill makes the core yarn 13 to 18 gauge core yarn seamless knitting, palm coating restores the grips needed. So, at the palm we should have coating, because to improve the grip. So, the outdoor exposure is due to UV resistance. HPP holds strength and color better than the para-aramid in sunlight. So, suiting outdoor handling task. Okay. So, we have in case of any outdoor performance, there we can use this ultra high molecular polyethylene, chemically harsh workplace or laundering intensive use. So, it is basically as it is a inert material. So, we can use the places where acid, alkali, solvent are used, they are that resistant, so enables the broader detergent bleach choice and robust washing during the cleaning of the HPP garment. So, here we can use any type of detergent for cleaning. Next material is that stainless steel and their blends. So, stainless steel fibers are widely used for this, particularly filaments are widely used for cut resistant textiles. It is fine single filament stainless steel wires, typically 20 to 60 micron, generally 30 to within 30 to 50 microns are generally used, and but main problem here is the comfort. Okay. Here we can use in the core, but in the sheath we can use other fibers. The combination we can use, that we will discuss in detail. So, typically 30 to 50 microns are used, they are incorporated into cut protective yarns as a core or as a wrapping filament. Okay. So, in the core we can use, so this is the filament, stainless steel filament, and in the sheath some other fibers can be used, like ultra high molecular weight polyethylene we can use there. It can be used as a wrapping filament, okay, because here in the wrapping we can also use, because in the core this filament will be there, in the wrapping other fibers can be there. Obviously, the thicker wire will produce higher cut resistance than thinner wire, but thicker wire the problem would be that its flexibility will not be there, it will be weight will be more. So, we have to optimize this thing, but stainless steel filaments are widely used in cut protection, particularly when threads are very high. So, its blends means here stainless steel and blends means, that means it is not normally used in single in only stainless steel is not used normally, but in some extreme cases where extreme hazards are there, like meat processing, butchery. So, these applications where we use 100% steel wire. So, steel wire shows very high cut resistance and it is used either in full chainmail mesh like this, where it is made of the only steel fiber, steel filaments for extreme hazards. Okay. That is one way of using, but or stainless steel reinforced yarn. In the core there will be stainless steel filament, and where pure aramid and high performance polyethylene or glass reinforced options are not sufficient. So, aramid and para-aramid or ultra high molecular polyethylene we can use for cut protection, but where the cut threads are very frequent and very high, there only these fibers will not be sufficient, and we can have the product with the this combination of stainless steel along with these fibers. So, they are coat sheath fiber or in the wrap type of structure, wraps yarn we can use. So, this detailed study has been carried out that will show the result subsequently. Now, stainless steel blends for composite yarn processing. So, composite yarn we use in coat sheath type of yarn or wrap yarn processing, and the stainless steel must have breaking elongation more than 10%. That is very important, because if the fibers, that stainless steel's breaking elongation is less, if it is not ductile, that means the inner core will break, which will have the problem during the wrapping, spinning or knitting process. Okay. So, that for that we have to have higher elongation. So, sufficient ductility should be there. So, post drawing annealing is used to reach this elongation. So, annealing is required after drawing to enhance the elongation. Now, in continuing with the properties, the machines and geometry. So, that mechanics and here the mechanics and geometries are here. The thicker steel wire yields higher forces, where in the different types of machines where the cut threads are high, in that case we use the thicker wires. So, thicker wire steel wire, because it yield high force than the thinner wires. Even at equal steel weight, highlighting the role of the contact mechanism and indentation. Okay. So, if we have higher thicker yarn, so the contact area will be high. So, in that case the for a certain force the pressure will be reduced. Okay. And this is basically for any product with a stainless steel and its blend for testing in the for cut resistance. So, where electrical conductivity is important. So, all this cut resistant testing are based on the electrical conductivity of the material. So, electrical conductivity test is there. So, for both there are two types of tests available, we will discuss in detail. One is Coop test and another is the TDM type, TDM which is followed by ISO 13997. So, in these methods they detect the cut through by blades conductivity, that is important. Now, here if you see there will be connector, we will discuss in detail, and here is the metal blade. metal blade is there, this is a metal blade, or knife, this is a knife, okay, cutting knife, and here is the anvil which supports the specimen. Now, this is the specimen which supports the specimen. Now, this knife moves to and fro or maybe in one direction. Due to this movement, the specimen cuts, and this anvil is a metal. Anvil is metal, and this is also, knife is also made of metal. Now, when there is no cut, there is no electrical connection, the material will move, the knife will keep on cutting. But as soon as there is a cut, hole created, immediately the metal will be in contact with the anvil, and that will stop the cutting process. Suppose before it cuts, suppose there is a movement of say total movement say 50 millimeter movement, or for say 20 millimeter movement we need a load of say x gram force or x Newton force is required. So, that will be giving the cut resistance characteristics. Now, if the material is made of stainless steel SS, in that case what will happen? Instead of before it reaches this anvil, and this is a made of say this is a stainless steel, and there is a covered yarn by stainless steel core, and sheath is say ultra high molecular polyethylene. This fabric we have prepared, and as soon as this top portion core is cut, the total fabric is not totally cut. So, core is cut, immediately there will be a contact, and that will create a false reading and stop early before it cuts. So, that is the main problem of testing both by Coop method and TDM method, where we use the stainless steel and blend because of the conductivity. They work with on the principle of conductivity, electrical conductivity. So, if the blade touches the conductive steel wire without any cut, without touching this anvil, it immediately stops. So, for that we have to do some insulation underlying that. Okay. So, use a thin filter paper or plastic film under the sample to avoid the inflated results. The properties you can see: comfort and mass trade off. That is the main problem with the stainless steel protective textiles. It is a heavy weight. The chainmail is a very commonly used with all steel mesh. So, 100% steel mesh is used for very high protection, where very high threat is there, and these are not flexible, not that flexible. They feel cooler because of they feel cooler because of the stainless steel, 100% stainless steel. So, it reserves for very high hazards, where only very high hazards are there. So, we have to use only in those applications, but steel reinforced yarns provide a middle ground. If we use as a core steel stainless steel and sheath with other fibers like pararamid or other fiber, there this type of problem of cooling problem will not be there. Okay. So, it will have middle ground, but adds to the mass and stiffness. So, basically problem would be that you are keeping the stainless steel same, but we are adding some additional fiber to improve the comfort or flame your softness, but we are adding the mass and also it will become stiffer, more stiffer. So, careful yarn engineering is required. Main applications are for stainless steel and blends where extreme hazard is there. So, full steel chainmail gloves or aprons are mandatory in butchery and meat processing. So, their extreme cut threads are there. And mainstream PPE, personal protective equipments, are steel reinforced yarns, steel core and organic fibers are in the sheath like pararamid, ultra high molecular weight polyethylene we can use at the sheath, where pure HPPE or aramid or glass blends are insufficient. So, only HPP or aramid or glass blends are they can give protection up to a certain extent, but where extreme hazard threats are there we need stainless steel reinforcement, or where TDM based performance is the prioritized. Now, let us see what are the different types of yarns which are suitable for cut resistance. Typically, we use filament yarns of different structures, okay, and also different types of bicomponent yarn we use, different types of staple spun yarns we use along with the filaments, like mainly we use the core sheath type of yarn in this cut protective textiles. Also ring spun core spun yarn made from the ring spun spinning process, open end process, friction spinning, wrap spinning. So, different types of spinning process we through this spinning process we develop different types of cut protective yarns. Now, the staple spun yarns are used from the short fibers. It is high cohesiveness from the twist, These are easy to knit or weave and frequently used in 7 to 10 gauges lines. Filament yarns are also used, which are basically continuous filaments for their high tenacity than spun yarn. They are often paired with wrapped spandex or FDY, DTY, drawn textured yarn in fine gauge. Textured or interlaced yarns are used. They add bulk, cohesion and kneatability with a heavy twist. So, air textured yarns are used for their warmth, twist level we can change. So, there are optimum twist, too little twist will reduce the cohesion and too much twist, too high twist will have the tight yarn, harsh yarn, and they will make the yarn brittle and which degrades the performance. Piling and cabling are also used, combining ends where multiple ends are combined to adjust the linear density for a target gauge or our that requirement, the strength requirement or protection requirement. We can use the ply or cabling. Texturing also are important. So, to improve the cohesion or handle without resorting to the very high twist. So, that air covered yarn, the different types of yarns we can use. Composite coarse sheath yarns are very commonly used for cut protective textiles. Coarse spun wrap covered designs are used. Steel or glass as a core with polymer, aramid, HPP, that sheath is isolated, which are basically from the hard component. In the core we can use the high strength fiber like steel or glass. If it touches, these are the hard surface, if it touches our skin, there may be irritation and may not be comfortable. For that we coarse spun yarn or wrap covered yarn we can use. Wrap or coarse spun construction are used here. Now, this is the multi component yarn, where this is core, first sheath and second sheath. Multi layered yarns also used. So, steel cores are typically 30 to 50 micron, 30 to 50 micron. A typical range is 30 to 50 micron and total range is between 20 to 60 micron range. Thicker wire yields higher strength and higher cutting force. As we have discussed already, the breaking elongation should be more than 10%, which is achieved via annealing, and to survive, this is required to survive during the elongation, during spinning, knitting and during wear also it should not break. So, there should be some elongation, and here the sheath, this is the core, typically glass or stainless steel is used, and sheath, the HPP is used, high performance polyethylene. is used, and due to very low frictional contact, this HPP may slip through the core. Okay, that means yarn structural cohesion may not be there, and that is why HPP is rarely used in the wrapping of the steel. Okay. Now, here in our experiment, what we have done, we will discuss. In the second core we have introduced, where we have used a polyester fiber, PET fiber we have used, which is actually has got higher friction. So, it will hold the HPP along with the core. So, that we have introduced. We will discuss this the study. The staple fiber core span cover holds the steel more securely. Okay. So, that is why here we use the staple fiber sheath also. So, it reduces the exposure and improve the comfort. So, another staple fiber we have used here. Now, after the fiber and yarn structure, now let us try to see the fabric structure. So, in the cut resistance, particularly for gloves and sleeves, majority of the products are dominated by the knits. These are basically knits due to the stretchability, okay, of the knit structure, and this even gloves if we made from the woven fabric, due to the less stretchability, it will not be comfortable and it will restrict our body, that is a finger movement. But some applications, not the cut, but many applications where we have to use the woven gloves also we can use for different applications. So, it enables seamless 3D lines. So, we can use the gloves or sleeves, seamless gloves, there is no stitching required. So, that is the advantage, the 3D lines we can produce, and also seamless garments are also, knitted garments are nowadays produced from this type of cut protective yarns. So, that fits this closely and reduce the irritation from the seams. So, during the stitching there may be some other threads and there may be some thick portion doubling of the fabrics are there before we stitch, and that adds to the irritation. Okay. So, there if it is seamless, then there will not be any thick portion within the joint. So, proper movement of the fingers or the sleeves will be there. That is hand movement, or even if we produce the garment, full garment made of the seamless knitting, that will also help us in improving the comfort and ergonomics. The loop structure provides natural stretch. So, it is and recovery. So, that is stretchable and which improves the dexterity and comfort. So, a person can work for long time with a particular concentration So, that is important due to in the knit structure. It is efficient and suitable for mass production. So, that is important for because it is was seamless one go. So, we can have mass production and supports plating. So, here we can also in knitting we can use the plated structure. Plated structure means in we can have multi layer, 2 layer. This is top layer and here there will be bottom layer. Okay. This is the bottom layer and one is the top layer. This is the same high performance yarn. It may be made of any pararamid, HPP or stainless steel, but in inside we can have like cotton. So, in knitting it is possible to produce the plating structure. So, hard fibers are at the surface, soft fibers are at the inside, which is in touching with our body part. So, that will improve the comfort. At the same time the protection level will be intact. And apart from this knitted fabric, we can use the woven fabrics, and after producing we cut and sew. So, cut and sewn woven fabrics are used. The complex shapes apron sleeves are often cut and then we stitch it from the woven fabric. In case of knitted fabric, we can have produced in one go, okay, 3D knitting machine, okay, like garment knitting or gloves knitting, but here we have to for a apron and sleeves for woven fabric we have to cut and then stitch. So, that is why it is more labor intensive and suits non glove item. So, where flat item larger items are there, but in for gloves this woven is not used, because there we do not need any stitching, because that will hinder the hand movement, finger movement. Basis weight is preliminary driven by cut rating. So, if we need higher cut rating, so we can increase the mass per unit area. This is both for knits and wovens when other variables are held constant. So, we have to increase the mass per unit area to have better protection. Non-wovens are also used in cut protection along with the other type of structure, fabric structure. So, non-wovens are fabric made of forming fiber directly from fibers, then through bonding, okay, it without knitting or weaving. So, structure is held by entanglement, by needling, by water jet or thermal fusing. So, non-wovens are also used for this cut resistant product, but it is not that widely used, mainly dominated by the knitting followed by the weaving. But this non-wovens are used basically for providing bulk. This protection is basically is by providing bulk, cushioning, friction path, which helps with the slash, abrasion and spread local contact pressure under blade. That is the basic advantage of nonwoven. Because of the bulk, it when its pressure is there, it gives some cushion, and due to its thickness it takes longer time to pass through. So, friction path is longer here, and which helps the force, slashing or cutting force, to spread. The contact pressure is spread along the wide area. So, apart from this protection, there are other areas of which the nonwoven fabrics are responsible for, the mechanisms are there. So, this we will discuss, we will continue this topic in the next session. Till then, thank you.